The normal curve. The normal curve is an interesting distribution. It's one that looks like this. And we've seen graphs like this before. This is called a bar graph. And it's just taking the data, right? And the frequency is the height. But a normal curve is a special type of curve where, if I draw a line right through the center here, the normal curve has a mirror image on both sides of this line, and it looks identical on both sides of this line. And so we say the graph is symmetric right here. Now also, if we draw a line through the center of each of these bars, we will have a graph that looks like a bell. And so this is called a bell-shaped curve. An interesting thing about the normal curve is that we can see where the mode is, right? The mode is right here. And that's the most frequently occurring piece of data. It also happens to be the median because half the data is below this score here and half the data is above this score. And it also happens to be the mean, the average. Okay, now if we go one standard deviation above the mean, we will always have approximately 34% of our data. If we go one standard deviation below the mean, likewise, we will also have approximately 34% of our data. Which means that if we go one standard deviation below the mean to one standard deviation above the mean, we will have approximately 68% of our data, always. If we go two standard deviations above the mean, we will have approximately 47.5%. If we go two standard deviations below the mean, likewise, we'll have approximately 47.5%. So going from two standard deviations below the mean to two standard deviations above the mean, we'll have approximately 95% of our data. And going three standard deviations above the mean to three standard deviations below the mean, we will have 99.9% of our data. Now we see that the mean, median, mode are the same, which means that the percentage of data above the mean is going to be 50%. And the percentage of data below the mean is also 50%. So 50% of our data is above the mean and 50% of our data is below the mean. Okay, now we don't have to have these memorized, but there's a table. You see, going one standard deviation away from the mean is approximately 34% of our data. And I want to show you a table. And the table that I'd like to use, it's called a z-table, looks like this, where we have two columns. We have a column labeled Z, and a column labeled A. And so we have our z-score, and we have our area underneath that curve. Now the z-score is the number of standard deviations away from the mean. So if we have a z-score of 1, we look down our column under z, we have a z-score of 1, you see we see 0.341. We have 34.1% of our data approximately. If we have a z-score of 2, that means we're 2 standard deviations away from the mean. Then we have approximately 47.7% of our data, 0.477. And so this is how we read this table. And so the way I'm going to explain these problems is by the z-score being the number of standard deviations we are away from the mean. Now, the author in this newest edition likes to use a different table, and that's okay. You know, you can use whatever table you like. I found this one to work the best. And there's also other tables. You know, if you take another statistics course, you know, the instructor may want to use even another table, a different table. But I find that this table works best, and I think it's easier. So I'm going to continue with this. So we don't have to have these z-scores, the number of standard deviations away from the mean, memorized. Okay, we have our mean median mode, which is the same right here. And this is our mean. And here, if we go 1 standard deviation above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean. Minus 1 standard deviation, that minus sign just means that we're going to the left. Okay, so it's 1 standard deviation to the left. Minus 2 standard deviations means that's 2 standard deviations to the left. And minus 3 standard deviations means 3 standard deviations to the left. Alrighty, in this example, it deals with IQ tests. Intelligence quotients are normally distributed with a mean of 100 and a standard deviation of 10. So find the percentage of individuals with IQs in the following ranges. Well, first we draw our table. We're told that the mean is 100. We're also told that the standard deviation is 10. So if we go 1 standard deviation above the mean, we're at 110 because we're told the standard deviation is 10. If we go another standard deviation to the right, we would be at 120. If we go another standard deviation to the right, 3 standard deviations away from the mean, we would be at 130. 1 standard deviation below the mean, right, we take 10 away from 100, we get 90. 2 standard deviations below the mean, we're going to be at a score of 80. And 1 more standard deviation below the mean, right, we subtract 10, we're at a score of 70. So in example A, we want to find the percentage of individuals with IQs between 100 and 110. Between 100 and 110. We have to find the z-score. And remember, the z-score is the number of standard deviations away from the mean. So we are 1 standard deviation away from the mean. Here's our mean. We're 1 standard deviation above the mean. Our z-score is 1. And I wrote a little subscript of 110 there. So this way I know that that z-score is for 110. I'm going to be writing down a few z-scores, and I don't want to get confused between them. So a z-score of 110, if we look up on our table, we'll see we get 0.341. or 34.1%. And so 34.1% of individuals get a score between 100 and 110. In example B, we want to know the percentage of individuals that get a score between 80 and 100. Well, 80 is 2 standard deviations away from the mean. So the z-score for 80 is 2, because we're 2 standard deviations away from the mean. So we look up on our z-table a z-score of 2, and we see we get 0.477, or 47.7%. In example C, to find the percentage of individuals with IQs between 80 and 110. Well, we've already found the percentage of individuals right here between 80 and 100, right? That's 47.7%. And we also found the percentage of individuals with scores between 100 and 110. So we add together the 47.7% plus the 34.1%. So we want to be careful. The way this table is written is it gives us the percentage of data, the number of standard deviations away from the mean. We do not want to look up 3 standard deviations. We look up 2 standard deviations below the mean, 47.7%, 1 standard deviation above the mean, 34.1%, and we add these 2 percentages together. Okay, in example D, we want to find the percentage of people who have IQ scores between 110 and 120. 110 and 120. Well, to do this, we need to find the percentage of individuals who have a score between 100 and 120. Well, from 100 to 120 is 2 standard deviations, so our z-score is 2. Our z-score is 2. Right, which means that we have 47.7% of our individuals that have a score between 100 and 120. Okay, we want to find only the percentage of individuals that have a score between 110 and 120. So we have to take away the percentage of individuals that have a score between 100 and 110. But we know that's 34.1%. So we take our 47.7% and we take away 34.1%. And we see we wind up getting 13.6%. So it's 47.7%, take away 34.1%, and we get 13.6%. Okay, in example E, we're asked to find the percentage of individuals that have a score below 120. Well, our z-score for 120 we have already found, right? That's 2 standard deviations away from the mean. Right, so we know that's 47.7%. And we also know that 50% of our data is below the mean, right here. And so we're going to take this 50% and add it to this 47.7% to find the percentage of individuals that have a score below 120. 47.7% plus 50% gives us 97.7%. Now in example F, we want to find the percentage of individuals that have a score above 115. Now, we notice that that's not even, that's not a integer number of ways of standard deviations we are above the mean. I want to show you a way that if you know this, you don't have to memorize any formulas. What I did was I drew a rectangle, and I divided this rectangle up into 4 equal parts. And I shaded part of this rectangle. And so if we know the part of this rectangle that's shaded, right, there's 1, 2, 3 parts that are shaded out of the 4 parts. 3/4 of this rectangle is shaded. If we know that, then there's no reason to memorize any other formulas. Because when we find standard deviation for 115, what we do is we count. From 100 to 110 is 1 standard deviation. And then from 110 to 115, 110 to 115 is 5 out of the 10, right? From 110 to 120 is 1 standard deviation. So we have 5 out of 10. And so the z-score for 115 is 1 plus 5/10. 1 plus 5/10, which is 1.5. So we look up on our table our z-score of 1.5, and we wind up seeing it's 0.433, or 43.3%. So we have 43.3% of individuals that have a z-score that has an IQ score between 100 and 115. But our question says what percentage of individuals have a score above 115? Well, we know that 50% of the individuals have a score above 100. That's 50%. So we just take 43.3% away from 50%, right? That's 50% minus 43.3%, and we wind up getting 6.7%. And so 6.7% of individuals have a score above 115. In this next example, it deals with heights of kindergarten children. So somebody just went around and just measured the heights of kindergarten children. And it's easy to make up one of these normal curves. We just take the average of the heights, we calculate the standard deviation, and we create a table. And that's exactly the same way our previous example with IQ tests were created. We gathered the scores of a lot of people, calculated the mean, the average, calculated the standard deviation, and we created a normal curve. Okay, so over here in this example, we're told that heights of kindergarten children are normally distributed with a mean of 40 inches and a standard deviation of 6 inches. So we know the mean is 40. Since the standard deviation is 6 inches, if we go one standard deviation above the mean, right, we add 6, we're at a height of 46 inches. If we go another standard deviation above the mean, we're going another 6 inches, we're at 52 inches. Okay, if we go 3 standard deviations above the mean, right, we add another 6 inches. Okay, if we go one standard deviation below the mean, we subtract 6 inches, right, we get 34 inches. If we go one more standard deviation below the mean, we subtract 6 inches, we're at 28 inches. And if we go a third standard deviation below the mean, we subtract another 6 inches, we're at 22 inches. And this information we have to be given. We're always told the mean, and we're always told the standard deviation. Now in example A, we're asked to find what percent of kindergarten children are between 40 inches and 46 inches tall. Well, 46 inches is one standard deviation above the mean, so we have a z-score for 46 of 1. The z-score of 46 is 1. So we go to our z-table, we look up 1, a z-score of 1, and we see we have 0.341, or 34.1% of our children. So the percentage of kindergarten children between 40 and 46 inches tall would be 34.1%. In example B, what percentage of kindergarten children are less than 46 inches tall? Well, we know we have 34% of the children between 40 and 46 inches tall. And then the number of children that are shorter than 40 inches would be 50%. And so the percentage of children that are below 46 inches in height would just be the 34% plus 50%. And we get 84.1%. In example C, finding what percent of kindergarten children are between 34 and 46 inches tall. Well, our z-score for 34 is 1 because we're one standard deviation below the mean. And our z-score for 46 we already know is 1, is 34.1%. And so the percentage of children that are between 34 inches in height and 46 inches in height would be the 34.1% plus the 34.1%, which gives us approximately 68.2% of the children. If 1,000 kindergarten children are selected at random, how many will be less than 43 inches tall? Well, we have to find our z-score for 43 first. So notice if we count from 40 to 43, we are going 3 units. We're going 3 units out of the 6 units from 40 to 46. And so our z-score for 43 would be 3/6 or 1/2. We could write as a decimal as 0.5 because we're looking this up on the table. And so if we look up a z-score of 0.5, being careful, It's 0.5 or 0.50, right? That's 1/2, right? We look up 0.50, that's 1/2. We'll find 0.192 or 19.2%. And we know we have 50% of our children below 40 inches in height. And so we have this 19.2% plus 50%. We have about 69.2% of our children that are less than 43 inches tall. Now our question says if 1,000 kindergarten children are selected at random, how many will be less than 43 inches tall? Well, it would be 69.2%, right? 0.692, 69.2%, times the 1,000, which would be approximately 692. 692. And that would be our answer. I have at least one more problem on the PowerPoints that I sent you online. If you want to look at those, you can. And they're done exactly the same way as this one. But this is the normal curve.